Hello friends, this video on Haloalkanes and Haloarenes part 22 is brought to you by examfear.com. No more fear from exam. Let's talk about the concepts for elimination reaction. We have learned substitution reactions. Let's talk about the concepts of elimination reaction because the next few slides we'll be learning more about elimination reaction. So elimination reaction scenario can happen as the guy is attracted by a base. Base is nothing but the money. So in this case, the person is attracted by the money. So this lady is alone. So we have already discussed the scenario. There's a chair and we have a guy and a girl sitting in the chair in a park, and that's the bond. There's a bond between them. So the guy leaves the chair because they're attracted by money. In chemistry world, it is nothing but a base which attracts hydrogen, because this is hydrogen in our chemistry world and this is a base in our chemistry world. The base attracts the hydrogen. This place is empty. Now there are other possibilities that some other hydrogen comes and joins this place, or if this lady's bored or any halogen is bored or halogen comes out. So when the lady is bored and she comes out of the place or she leaves the bench, and in this case a double bond is formed. This is a typical example of elimination reaction wherein the guy is attracted, or the hydrogen is attracted towards base or money. So there's a partial negative charge here, and with this partial negative charge, that is nothing but partial negative charge is developed here, and that is nothing but in the real world loneliness, right? So the lady is lonely and she also leaves the bench, and then a double bond is formed. Let me show you once again. So the person is attracted by money, the girl is lonely, and she also leaves, and the houses, the bench is vacant now, right? This is a typical example of elimination reaction. There can be another scenario also wherein the girl first leaves. The girl first leaves because of so many factors. Maybe the environment is protect. The environment favors the girl to leave, right? Maybe the environment is not good for the girl to sit here. The girls leave. The guy feels lonely, and the guy is also leaving the place. He is attracted by some other things, for example wealth, and then again a double bond is formed, right? So there are two scenarios. In one case we have seen the first scenario where the guy first leaves, the girl is lonely, she also leaves, a double bond is formed. Second case, the girl first leaves, the guy is now lonely and he is now attracted towards base, and a double bond is formed, right? There are two kind of elimination reaction. In one case the hydrogen first leaves, in the second case first the halogen leaves. So we'll see both these kind of reactions, right? So before we even go for different kind of reactions, elimination reaction, let's understand this protic and aprotic solvent. We have discussed this in class 11th also, what is protic and what is aprotic solvent, and this is a little critical because in most of this reaction we'll talk about protic and aprotic solvent. So what are protic solvent? Protic solvent is nothing but a solvent that has hydrogen atom bonded to an oxygen atom. For example, here if you see water, it is something like this, right? There is a hydrogen oxygen. Here also hydrogen is bonded to oxygen. This is methyl alcohol, ethyl alcohol, all is carboxylic acids, right? So if you see, hydrogen is bonded to an oxygen. This kind of solvent is called protic solvent. Why? Because they can donate protons, right? From proton, this word protic came because they have tendency to donate protons. They are called protic solvent. And aprotic solvents are those that they cannot donate hydrogen. For example, if you see acetone, it doesn't have any OH bond. It cannot donate hydrogen. If you see DMF, dimethyl formamide, if you see this guy also is not having any OH bond, right? This is carbon here. There's a CH bond. There's a hydrogen in this. There's a CH bond, but there is no OH bond. So it cannot donate hydrogen, right? So there can be other example. For example, this is acetonitrite, dimethyl sulfoxide. These are all my protic solvents. This is my dimethyl sulfoxides. This is acetonitrite. So all these are my protic solvents. Before we even discuss different kind of elimination reaction, let's understand protic and aprotic solvent. We've discussed this in class 11th also, but just let me repeat protic and aprotic solvent. So protic solvent is nothing but a solvent that has hydrogen bonded to oxygen. For example, in this case H2O, if you see, right, there is a hydrogen bonded to oxygen. CH3OH, methyl alcohol, if you see, there is a hydrogen bonded to oxygen. Ethyl alcohol, all this carboxylic acid, if you see, there is a hydrogen bonded to oxygen. And since OH bond is not that strong bond, they can easily donate H plus ion. So they are proton donors, right? So that's why this word protic came. They can donate protons, right? So proton donor, protic. And aprotic are the one, they cannot donate proton or they cannot donate hydrogen. For example, if you see this is acetone, this cannot donate hydrogen, right? This is my DMF dimethyl formamide, right? This is my acetonitrile, this is my DMSO, that is dimethyl sulfoxide. So all these guys, right, there is a CH bond here, but there is no OH bond. So there is no OH bond, there is no OH bond. Since there is no OH bond, they cannot donate H plus. So protic solvent, the solvent which can donate protons, and aprotic are the one which cannot donate H plus. And this plays a critical role in the reactions, right? So the same reaction, the same substrate, the same reagent with aprotic and protic solvent, they behave differently because H plus ion has a very critical role in the organic reactions, and that's why we are stressing on the protic and aprotic solvent. This plays a critical role in a particular reaction. So let's start the first kind of reaction, that is even reaction. Even reaction is the one which happens with a weak base and protic solvent, weak base or protic solvent. Let's understand the even reaction. So E1, as the name suggests, is unimolecular elimination reaction. Similar to SN1, we have E1, where the rate determining step is only one step, right? Here also we get the formation of carbocation. So if you don't know SN1 reaction, I highly recommend you go and watch my previous videos on SN1 and SN2. Before you watch E1 and E2, it's must to watch SN1 and SN2 reaction. So let's start with E1 reaction. E1 is nothing but unimolecular elimination reaction. So it is two-step process. It is two-step process, but only one step is the rate determining step, and this is the rate determining step, that is ionization, and the other step is deprotonation. So let's see this reaction here. So this is my substrate, right? And as I told, this happens in a weak, this is a weak base. And let's suppose this is happening in a protic solvent, because we don't need anything which has H plus, right? If something with H plus comes, it will consume this base, right? So since the base is weak here, so what happens in the first step is similar to SN1, right? Sorry, since the environment is protic, this Br minus will leave. So this protic solvent is helping Br minus to leave, and it becomes a stable carbocation. You see 1, 2, 3 degree carbocation, right? 3 degree carbocation. This is a very slow process, and this is my ionization. And then what happens is deprotonation. That means you take out a hydrogen. Now, since there is a weak base here, this is a positive charge here, right? This is a little unstable. It will be very good if something with a negative charge comes. For example, let's suppose I minus or Cl minus comes and again join this carbon, green carbon, or if possible remove this hydrogen, correct? In both the case my compound will be stable, but we don't have anything that can come. There is no halogen extra in this environment that can come. So the only thing can happen is there's a base here, then this base can consume this hydrogen. So if you see, this base is attacking this hydrogen in blue, right? This base will attack this hydrogen in blue and will take this hydrogen, and with that, if you see, there's a double bond that will be formed. Correct? We'll see this once again. Let's complete the other things in this. So if you see, this even reaction is a unimolecular elimination reaction, two-step ionization, deprotonation. So this is my ionization, and then this is deprotonation, because here I am removing a proton, right? And it typically takes place with the tertiary alkyl halides with 3 degrees. So if you see, why 3 degrees? Because the main step is this step where you form the carbocation. The ionization is the main step, and this ionization is favored for 3 degree carbon. So tertiary alkyl halide it favors. And if you see, as I told, the rate is influenced only by the concentration of alkyl halide. So experimentally it has been observed that if you increase the concentration of alkyl halide, the rate of reaction increased. If you increase the concentration of, let's suppose, ethyl alcohol in this case, which is a reagent, the the rate of reaction is not changed, right? So that means experimentally it is seen that the rate of this reaction depends only on the substrate. This is favored by a protic solvent. Why protic solvent? Because this protic solvent assists the ionization of the leaving group. So here my Br is the leaving group. So if the solvent is protic, it favors, because this Br minus can attach with H plus somewhere. So it becomes HPl. So this protic solvent favors this leaving group to leave. And this generally occurs in acidic condition. There is nothing but you can say the protons are there, this protic solvent, and high temperature. Correct. So this is similar to the example where I have seen there was a bench and there's a lady here and there's a guy here. So let me differentiate lady with the hair, and there's a guy here. So now in this is the example where the lady leaves first. That is my bromine leaves first. And then this guy, there's a wealth here, money. I'll say money, 1 rupee coin. Yeah, money here. And this guy is nothing but the base. And this guy is attracted toward the base, and there's something called deprotonation that happens, right? And then there is a double bond form. So same thing if you see here. What is happening here is my bromine is leaving. I get cation, carbocation, right? And now I have got carbocation. With this, now I have an alcohol here. It's a weak base, but see, typically alcohol is a weak base, or C2H5O minus. It is not alcoholic. Actually, it is C2H5O minus K plus. So we are using here C2H5ONa or C2H5OK. Please note, we are not using C2H5OH. So there is a difference between these two. These two are almost same, because in both these cases we are getting O minus Na plus, right? And in this case we'll not get O minus Na plus, but what we are looking for is C2H5O minus. So we'll discuss about these things when we talk about the strong and weak nucleophiles, which one is strong, which one is weak. But just try to understand here is that I'm not using here C2H5OH. What I'm using here is C2H5ONa or C2H5OK, because this gives C2H5O minus nucleophile. Correct? C2H5O minus is a good nucleophile, and it's a good base also. It's a very strong, it's a good base. It's a weak base, but it's a base, right? It's a base. So typically C2H5O minus will not be able to take out proton directly, but since it's a positive charge and this compound wants to get rid of positive charge, there are two possible options for this compound, right? So this one we have discussed in SN1 also. This can happen, right? Because this is a tertiary carbon with a bromine. So since the solution is protic, this favors bromine to leave. So bromine leaves and becomes a positive charge here. Now this positive charge it has to get rid of. So there are two possible options. If there is one more, let's suppose Cl minus here in the solution, then it can attack here and it will be a substitution reaction. But since there is no Cl minus here, or there is no one to substitute here, so the other option we have seen is there is a weak base here. It can take out this hydrogen, and even if it gets rid of hydrogen, it will become stable. So if you see this positive charge, this bond breaks in this fashion, right? So this gets positive and this gets negative, and this positive and negative charge combine to form a double bond. See, there's a double bond here. This new bond is a double bond in the red. So if you see what happened, this bond broke and this charge went in this direction. This bond broke. It had, if you see, there were two electrons that formed this bond. Both this electron went to this carbon. It got a negative charge. So now if you see, there was a positive charge here, negative and positive charge combined to form a bond, and that is the reaction, even reaction. So here in the real life scenario, the girl leaves first and the guy is attracted by the wealth, that is nothing but my deprotonation. The girl leaves, that is ionization, and then there's a double bond formation. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.